Hello, wonderful people. Here we are, chapter 37, section number 4, motor and generator comparison. So this is going to be a lot of review from before. We're just going to compare motors and generators and make sure we understand what's going on there. Come on, clicker, click. Moving charges experience a force that is perpendicular to both their motion and the magnetic field they traverse. An electric current is deflected in a magnetic field, which underlies the operation of the motor. Electromagnetic induction underlies the operation of a generator. We will call the deflected wire the motor effect and the law of induction the generator effect. So we're just trying to make these things simple and keep it grounded in the real world. In the real world, we have things that are motors and we have things that are generators. So we've seen this a few times now. When the current is going this way and the magnetic field lines are going that way, that means that the force that the wire will feel will go up. The wire will get pushed up out of the coil just because there's electricity moving through it, and that electricity is going through a magnetic field. That's the motor effect. Moving charges in a magnetic field mean that the wire gets pushed. B. When a wire with no current is moved downward, the electrons in the wire experience a force creating current. So, if you push the wire down in the direction of the black arrow, that wire is crossing a bunch of magnetic lines. The lines are going across from the north to the south pole of the magnet. And that means that if you're pushing down, you're going to have a force to push the electrons that way through the wire. Okay? So this is the motor effect. You put a current through it and the wire moves. This is the generator effect. You, the generator effect, I started to get it backwards in my mind. The generator effect means that when you, I'm still getting it backwards in my mind, so I don't want to say anything until I've got it straight in my head. The wire is moved downward. That's it. I got confused because this black arrow is pointing towards the word moving charges. That's what was confusing me. So you push the wire down, and then the electrons get moved in that direction. The motor effect occurs when a current moves through a magnetic field. The magnetic field creates a perpendicular upward force on the electrons. Because the electrons can't leave the wire, the entire wire is tugged along with the electrons. So they're just saying that the force that's on the wire there, well, that's because as the electrons are moving this way, they're getting pushed up. That's the resulting force. And so it's not the wire that's getting pushed, it's the electrons in the wire, and the electrons bring the wire along with it. Okay? In the generator effect, that one, a wire with no current is moved downward through a magnetic field. The electrons in this wire experience a force perpendicular to their motion, which is along the wire. So a current begins to flow. Oops. So as you're pushing it down, the electrons moving through this magnetic field feel the moving magnetic field, and that means they get pushed in that direction. Okay. Now, in the real world, there is one time nowadays where we have an example of something that does both a motor and a generator. A striking example of a device functioning as both a motor and a generator is found in hybrid automobiles. When extra power for accelerating or hill climbing is needed, this device draws current from the battery and acts as a motor. So it's where's the good picture? Something like this. But when you need more power, instead of a light bulb, it's the battery, and the battery puts electricity in, and now it pushes this to go faster, and that drives the wheel. So now the car will accelerate faster. Braking or rolling downhill causes the wheel to exert a torque on the device so it acts as a generator and recharges the battery. So when you're braking, this is moving and they take the power and it generates electricity and they take the electricity out and put it into the battery. So as this is spinning and making electricity, well, that's slowing down the wheel. So the wheel that's turning starts to get slowed down because the energy from the wheel is going into here and coming out as electricity. So sometimes in the hybrid, the device function as a motor, and sometimes it functions as a generator. Pretty neat. How does a magnetic field affect a moving charge? So, if a moving charge is going through a magnetic field, it gets pushed in a direction. I don't want you to have to worry about what direction. And that's the end of that section. We'll start with section 5 next. Thank you so much.